Hello everyone, welcome to our day 15 discussion. Today we are going to discuss about the storage in Kubernetes. Let's do a quick recap what we have discussed in our day 14. In day 14 we discussed about the taint and toleration. Okay, the taint is applied at the node level and toleration is applied at the pod level. And the next thing which we discussed is the difference between the taint and toleration and our node selector and affinity. Okay, so taint and toleration is all about the node purpose, and node selector and affinity is dedicated for the pod purpose. Okay, so let's start our today's discussion. The first thing which we are going to discuss is about the empty dir. Okay, so what is the exact meaning of empty dir? I would say we have this pod. Okay, and inside this pod we have two containers. Okay, the container 1 and container 2. What I want in this example is to share a volume between them. Okay, which means if I'm going to store anything inside this container 1, I would say a file name called ABC, it should be visible inside the container 2. Okay, so to achieve this one, what we have to do, we have to create a common volume. Okay, or I would say common directory, and then this volume it would be common between the container 1, sorry, container 2 and container 1, and this one it is called as empty dir. There is one typo, so it is called as empty dir. So what is the exact purpose of empty dir? I would say the first purpose is to share a directory between containers. Okay, so I have created this folder on a name of emptyDir. It would be shared between the container 1 and container 2, and then whatever the things I'm going to mention in container 1 on this path, automatically it will be available inside the container 2. The second thing is, by default this folder is empty. That's why it is called emptyDir. EmptyDir means empty directory. And the third one is the life of the life of emptyDir is directly proportional to the pod life. Okay, so what is the exact meaning of it? I would say I have this pod name called P1, and inside this P1 I have two containers, container 1 and container 2, and both of them have mounted this empty dir. Okay, so if I'm going to store the data inside this empty dir, so it will be shared between the two containers, but once I'm going to delete this, the data will also be deleted. Okay, so let's do a quick demo to understand it. I have already created a cluster name called as demo-aks. Okay, let me quickly connect to this cluster. Okay, let me open my cmd. I have set the subscription. Let me copy the cluster credentials. We'll paste it here. My cluster is connected. Let me run kubectl get nodes. Okay, so my cluster is connected. Let me open the Visual Studio Code. We'll create a YAML file name called as emptydir.yaml in folder. If you see here in this YAML configuration, we are trying to create a pod, and the name of my pod is pod emptydir. So I would say the name of my pod is pod emptydir. Okay, then I have created two containers name called as C1 and C2. The name is C1 and C2, and the image is nginx here. Then I have mentioned the command which is going to run inside my container, the same here. Then I have mentioned regarding the volume mounts, and here also the same one. Let's firstly discuss the line number 19 to 21. So in line number 19, what I'm creating? I'm creating a empty dir. Okay, we already have a detailed discussion what is the exact meaning of empty dir and why we need to create it. The name of this empty dir is exchange. Okay, and this empty dir will be shared between the C1 and C2. And if you see on line number 10, what we are doing? We are doing volume mounts. Means this volume, whatever the emptyDir we have created, it is going to be mounted in our C1 container on this path. Okay, forward slash tmp forward slash exchange. The same with container C2, my emptyDir exchange will be mounted on path tmp forward slash data. So if we are going to save any file name called as I would say C1 inside the C1 container, when we are going to log in inside the container 2 and follow this path, we will be able to see the C1 file which we have created and vice versa. Why? Because we have used the emptydir concept. So let's do a quick demo to understand it. Let me copy the path. Okay, I'll run a command called kubectl create -f emptydir.yaml, and let's run kubectl get pods. See, our pod has been created and both the containers are in a running stage. Let me log in inside the container one. Okay, and cd to this path. I'll create a file name called as touch-c1. We'll exit. There's one typo. And let me log in container c2, and in c2 it is mounted as forward slash tmp forward slash data, and let me run a command dir. See, we have a file name of c1 which we have created inside the container one. If here also if I'm going to create a file name called as c2, let me exit and log in inside the container one and cd to a path tmp forward slash cd forward slash tmp forward slash exchange, and let me run a command called dir. So we are able to see both the files. So what we have discussed till now, in a pod we are good to create a containers, and inside the pod we are good to create empty dir, and then this empty dir will be mounted in our containers, and whatever the things which we are going to mention here, it would be shared, okay, at a specific path. So the same thing we have done, we have created the two containers c1 and c2, and then we have created this empty dir, a name called exchange, and this emptyDir is mounted on this path in C1 and mounted /tmp data in C2. So in this path, if you are going to save anything, then in container C2 we would be able to see the same thing, and the vice versa. So this is all about the emptyDir. Okay. The second type of storage which we have is called as host path. Okay. So what we have discussed about the emptyDir. Okay. The challenge with emptyDir is related to the pod life cycle only. If my pod is going to be deleted, then automatically whatever the data I have stored inside the pod, it will be deleted. So the second option which we have is host path. So what is the exact meaning of a host path? I would say this is my node. Okay. And inside this node, my pod is created. I would say pod P1 is created. Okay. So what I'm trying to say here, if my pod is going to be deleted, means if my pod is going to be deleted, then automatically whatever the data was stored inside this pod, it would be deleted too. So to overcome this solution, the next option which we have is using host path. In host path, if this is my node, okay, so here I will get the storage using host path concept, and this thing is called as node only. Okay. Tomorrow if my pod is going to be deleted, and if I'm going to create a different pod with a name called as P2, then it is good to connect to my host path. So it is not related to my pod lifecycle. Okay. To implement this one, I'm going to use concept of persistent volume and persistent volume claim. And finally, the persistent volume claim is going to be mounted inside my pod. So now we are good to ignore what is persistent volume and what is persistent volume claim. We'll discuss about it, but let's implement this host path. So the first thing which I have to create is volume. We'll mention the configuration. Okay, let me exit from this container. Okay, I'll run kubectl create -f pvol.yaml. If you see here, my persistent volume has been created. I will run kubectl create -f pvol.yml. Okay, we'll run a command called kubectl get pv. Okay, my persistent volume has been created. Right now I'm not discussing what is exact meaning of persistent volume and all, but the logic is, firstly we have to create what? Persistent volume, then we are good to create persistent volume claim, and then finally we are good to create our pod. Okay, and persistent volume will get the storage from our node, and this type of configuration is called as host path. Okay, the second configuration which I'm going to create is persistent volume claim. We'll paste the configuration. I'm going to run a command called kubectl create -f pvc claim.yml. See here, my pvc has been created. Kubectl get pvc, and my pv is also created. Okay, so we are done with step 1 is done, step 2 is done. So finally what we have to do, we have to create a pod. So for creation of pod, I'm good to create a file name called as pod pvc.yml, and here I will mention the pod configuration. If you see here, what we are trying to create, we are trying to create a pod, and here's the name of my pod, and the container name is C1, and this is the image which we are using. And again the same concept is, we have mentioned the volumes and that volume is going to be mounted inside my container. For now, we are good to ignore this conceptual part. We'll discuss about it later on. But right now, what we are trying to achieve, we are trying to create a pod, and this pod will be linked to my PVC, and PVC will be linked to PV, and PV will get the volume from my node. Okay, so let me run the configuration. kubectl create -f pod pvc.yml, and finally my pod has been created. kubectl get pods, and if you see here, my pod has been created. Okay, so the first thing which I have to do, I have to log in inside the pod, and then inside this pod I need to go to this path, and we'll create a file name called as touch c1. Okay, and we'll come outside. So as I have discussed, from where we're getting a volume, we are getting the volume from our node. So to check if my file exists inside the node or not, what we have to do, we have to log in inside our node. Okay, so this pod has been created in, I'll say kubectl get pods -o white. Okay, so this pod has been created in this system pool. So means I have to log in inside this node, and then I have to check like, is it this c1 is present or not. Okay, so the command is kubectl. As I have discussed, we need to create one debugger pod inside this specific node, and the image is this one. Okay, let me press enter. So we are inside this system pool configuration. So we are inside this node. So here we need to check, is my C1 file created or not. To check this one, what we have to do, we have to check our persistent volume configuration. Okay, let me open my persistent volume configuration, and inside the persistent volume configuration I have mentioned the host path, and the path is inside node. So I will mention a command called as ls host / inside. So if you see here, we are able to see this file name called as c1, which we have created inside our container. So whatever the syntax I have mentioned to you, the node is the guy which is going to provide the storage, then node is connected to my persistent volume, then the persistent volume is connected to my persistent volume claim, and then finally what we have to do, we have to connect the pod with our persistent volume claim. Okay, this is the way of providing the storage to our pod. So till now we haven't discussed anything regarding the PVC and PV. So let's firstly understand what is the exact meaning of persistent volume and what is the exact meaning of persistent volume claim and why we need it. So let's firstly discuss about the persistent volume. Okay, so what is the exact meaning of persistent volume? So persistent volume is the main guy who is going to connect to our physical volume. Okay, so what is the exact meaning of it? So in our last example, what we have done, we were providing the volume from our node only. So who is the guy who connect to our node? Is the persistent volume. There, if you are using Azure, so in Azure also we are good to get the storage, or I would say disk. So who is going to connect to all this component using persistent volume? Or else if you are using NFS storage, network file storage, so persistent volume will be the point of contact to all this configuration, means all the physical volumes are going to connect to our persistent volume only. Okay, so let's create one persistent volume. We mention vol6.yml. This example, we are creating a new object called as persistent volume, and the name of my volume is pb6. And we are good to ignore this line number 6. We are going to have a separate discussion regarding the storage class name. If you see in this example, we are creating persistent volume. The name of my volume is pb6 and the access mode is read write many. Okay, so what is the exact meaning of access mode? So we have the three options. The first one is called as rwx, which means read write many. The second option is called as read only many, and the third one we have read write once. So what is the exact meaning of it? I would say we have node 1, node 2 and node 3, and we have created one volume. Okay, so eventually while creating the persistent volume, if we are going to mention read write many, it means n1, n2 and n3, all three nodes are good to read and write on this configuration at the same time. If you are going to mention read only many, which means n1, n2 and n3 can only read the data from this volume. And if you mention read write once, it means at any point of time only one node can read or write the data from this node. So that's the difference between the three configuration. And what is the persistent volume reclaim policy? We'll discuss about it. And finally, we need to mention the capacity. Capacity means what would be the size of this persistent volume we are creating. And finally, on the line number 12, we mentioned the host path. Okay, the host path volume will get the volume from our nodes only. Okay, so let me quickly create this persistent volume. Let me exit here, clear the screen. Kubectl create -f pvvol6 dot create a file. Will mention a file name called as kubectl create -f pvvol6 dot yml. And if you see here, my persistent volume has been created. We'll run a command called kubectl get pv. And if you see here, the persistent volume name is pv6. What is the size we have mentioned? We have mentioned 3 GB. What is the access mode we have mentioned? We have read write many, that's why it is coming as rwx. If you would have mentioned read only many, then it would be rox, and if you had mentioned read write once, it would be rwo. Okay, then we mention about the reclaim policy. We are going to have a separate discussion regarding this topic. Then we have the status, which means it is available. The storage class is hard disk drive, as I have mentioned here. Then volume attributes reason, and this is the age of our volume. So what we have discussed is we have the persistent volume, and the persistent volume will get the volume from our physical, also physical volume. Okay, so persistent volume is going to connect to our persistent volume claim. If you have noticed here, right now what I have done, I have only created the persistent volume. That's why the status of this volume is showing as available. Okay, and in terms of claim, it is blank. Okay, once I am going to create a persistent volume claim, then in that case the persistent volume and persistent volume claim will be connected to each other. So let me do it. I'll mention pvc6.yml. If you see here, I have mentioned persistent volume claim, the object type, the name of my persistent volume claim is pvc6, this is the my storage class configuration, and here I have mentioned the access modes, and here I have mentioned the 2 GB. Okay, so let me create. Before creating this persistent volume claim, I'm just going to update this one from 1 to 12 GB. Okay, and let me run a command called kubectl create -f pvc6.yml. Okay, so as we have discussed, let me firstly clear the screen. Let me run kubectl get pvc, and if you see here, my PVC has been created with the name of PVC6. The status is pending. Okay, and the storage class name is hard disk drive we have mentioned, and the age of this one is 21 seconds. If you have noticed, while creating the persistent volume, the size which I have mentioned is 3 GB. Okay, but in terms of persistent volume claim, I have mentioned 12 GB. Do you think this persistent volume can give the 12 GB of persistent volume claim? The answer is no. Why? Because the maximum value this persistent volume can give is only 3 GB. So in this case, either we have to create a new persistent volume with 12 GB, or we are good to decrease this one to 3 GB. Okay, so right now if you see, the persistent volume claim status is pending, and even in terms of persistent volume also the status is available. If I'm going to change this configuration from 12 to 1 GB, do you think it would work? The answer is yes. Why? Because here we have mentioned the 3 GB, and here we have mentioned the 1 GB only. Okay, so in this case it would work because 1 GB is lesser than the 3 GB. So the value of persistent volume claim should be equal to or less than the persistent volume to get attached. So let me create a new persistent volume claim. I would say PVC 7.yml. If you see in this YAML configuration, we have the persistent volume claim as object. The name of my persistent volume claim is PVC7, and the access configuration is same. But here if you notice, the size of this persistent volume claim is 2 GB, which means whatever the persistent volume we have created, a size of, I would say here, 3 GB, it is lesser than the persistent volume claim. So we are good to say whatever the persistent volume claim we are good to create, it should be less than or equal to the persistent volume. If this condition is not going to satisfy, then our persistent volume claim will be in pending stage only. Okay, so let me create the persistent volume claim pvc 7.yml. Okay, and let me run a command of. So if you see here in this kubectl get pvc, the status is bound, and the volume name is pv6. Okay, and let me check the persistent volume also, and my persistent volume also, it is the same thing. The status is showing bound. Okay, which what is the name of my persistent volume claim is pvc7. Okay, so we are good to say, as I mentioned here, the persistent volume is going to connect to my persistent volume claim, and there are some conditions. The one condition which we have discussed is the size of persistent volume claim should be equal to or less than the persistent volume. Okay, apart from the size, I would say, apart from the size, the other option is the access mode. The access mode of persistent volume should be equal to persistent volume claim. The third one is volume modes, and the fourth one is the storage class. So the storage class we are going to discuss, so we are good to ignore it. So the next thing which we are going to discuss is regarding the persistent volume reclaim policy. Okay, let me create a new file name called as pvol8.yml. Okay, and in this one I'm going to mention the, if you see here, what we are trying to create, we are trying to create the persistent volume, the name, the storage class. We already have a detailed discussion regarding the access mode. Then this part we have to discuss persistent volume reclaim policy. What we have mentioned, delete. Apart from delete, we have one more option which is called as retain. Okay, so let's firstly discuss what is the exact purpose of delete. Okay, I have mentioned the persistent volume reclaim policy as delete. Let's do a quick demo. I will run kubectl create -f pvol8.yml. Okay, let me update the name here and run it again. So my persistent volume has been created. Kubectl get persistent volume, ah, kubectl get persistent volume, and if you see here, the name of my persistent volume is pv8, the size is 3 GB, access mode is read write many, and the reclaim policy which we have mentioned is delete. And till now we haven't created any persistent volume claim. That's why the status of my this persistent volume is available. Okay, let me quickly create our persistent volume claim. Okay, the first thing I'm going to do, I'm going to create a YAML file pvc8.yml. If you see here, I have not mentioned anything regarding the persistent volume reclaim policy because this policy is applied at the persistent volume level only. Let me create my persistent volume claim. I would say pvc8.yml. It has been created. So, and what is the status? It is bound to my pv8 only. So what I have done, I have created persistent volume 8. Okay, and then I have connected this persistent volume 8 to persistent volume claim 8. Okay, so let me delete this one. Okay, the persistent volume claim, then check what is the status of our persistent volume. I will run a command called kubectl delete -f pvc8.yml, and finally my persistent volume 8 has been deleted. We are not able to see any persistent volume claim with the name of pvc8. Let me check what is the status of my persistent volume. If you see here, what is the status of my persistent volume 8 is failed. Why? Because while creating my persistent volume 8, what I have mentioned my reclaim policy as delete, which means if I am going to delete the persistent volume claim, then automatically the persistent volume will also be deleted. I'm saying it again. While creating my persistent volume, I have mentioned persistent volume reclaim policy as delete. Okay, which means if I am going to delete the persistent volume claim, okay, then automatically the persistent volume will also be deleted. That's why the status of this one is mentioned as failed. Okay, if I would have mentioned retain, I would say retain. So if I'm going to delete the persistent volume claim also, then my persistent volume will not be deleted. We have to delete it manually only. Okay, or else we are good to mount it to the new persistent volume claim. But my persistent volume will be available. So let's do a quick demo to understand this one. I'll create a file name called as pv9.yml. Okay, I'm quickly going to create kubectl, create -f pv9.yml. Okay, kubectl get persistent volume. And if you see here, the reclaim policy is retain. Let me quickly create a PVC for it. PVC 9.yml. And here in PVC, the configuration is same. Let me run. Let me update this PVC name to 9. Let's say PVC 9.yaml. Okay, my PVC is also created. If you see, PV9 has been created and it is bound to home to PV9. So let me delete this persistent volume claim which we have created. Okay, and then run kubectl get PV. If you see here, what is the status of my new PV is released only. Why? Because we have created our persistent volume using reclaim policy of retain only. Okay, so as we have discussed, if you are going to create a persistent volume with retain policy and then you are going to connect to persistent volume claim, if this guy is going to be deleted, our persistent volume will be still available. If I'm going to create my persistent volume with a policy of delete, and if this one is going to be deleted, then my persistent volume will also be going to be deleted. That's why the status is showing as failed. Let's do a quick recap. So with this we have completed our discussion for the persistent volume and persistent volume claim and finally creating the bot. Okay, the third option which we have to use is storage class. Okay, the third option which we have is storage class. So here comes very interesting question. Why we need to use a storage class? The logic is straightforward. Till now what we have done, we have created what? A persistent volume. Then we are connecting to our persistent volume claim. And finally this persistent volume claim is going to connect to our bot. Okay. This looks good in terms of lab or demo purpose. But in real time scenario, if you think we are going to have multiple applications. So in that case, it is very tedious task to create this persistent volume. So to sort out this one, what we have to do, we have to create a storage class. Okay. And then this storage class will be responsible to create what? A persistent volume. And finally, this storage class is going to connect to our persistent volume claim. And then we are good to do the mounting of this one inside the pod. So the process will be changed at this level only. Means the storage class will be created, I would say one time activity, and then we are good to consume this storage class inside our persistent volume claim. By default, there are so many storage class are present. Okay, let me run a command called kubectl get sc. If you see here, we have multiple type of storage class. Okay, all of this belongs to file level storage, which means a NAS solution. And if you see here the bottom one, all of them are disk level storage, I would say SAN one. Then we have the reclaim policy, which we have discussed, and the second one is volume binding mode. The volume binding mode, it means like once we are going to claim, so at that time only the persistent volume will be created. And if you are going to mention wait for first consumer, so it means it will wait for the pod to be created, then only the persistent volume will be mounted. But the the main story is, if you are going to implement the storage class concept, we are going to have the storage class, then our persistent volume claim, then have our pod. Okay, and the storage guy will be responsible to create the persistent volume. So I would say it would be one time activity, and then according to our requirement we are good to call this storage class and it will create the volume for us. So let's do a quick demo. Okay, so I'm going to create a file name called as sc.yml, and here I will mention the configuration detail. And if you see here, the kind is a storage class, the API version is this one. Then what is the name of my storage class? I have mentioned Azure Disk hyphen premium hyphen retain, and here I have mentioned the provisional. So right now I'm working in Azure environment, that's why it is mentioned as Azure hyphen disk. If we are going to work in AWS environment, then we have to mention the provisional for our AWS. We already have a very detailed discussion regarding the reclaim policy. One is retain and the another one is delete. Okay, and the volume binding mode also we have discussed. The first one is wait for first consumer and the second one is immediate. And allow volume expansion means according to the requirement it would be increased, and this is the parameters which we need to pass. Right now we are creating the premium LRS. Apart from premium, we have other multiple options which we are good to mention. Okay, like the premium one or the stand, and the other options we have is premium or the standard one. Okay, let me create the storage class kubectl create hyphen f sc dot yml. See our kubectl get sc, there's one typo. And if you see here, our storage class has been created and it has the same configuration which we have mentioned in our YAML file. The second thing which we need to mention is our YAML configuration for PVC sc.ym. And here if you see what I have mentioned, I have mentioned the persistent volume claim as a kind. This is the name of my claim, and here if you noticed I have mentioned the storage class name. It is the same name which we have created the storage class. Okay, and here I have mentioned the size of my storage which is 4 GB. Okay, let me create this one kubectl create hyphen f pvc sc.yml, and let me run kubectl get pvc. And if you see here, this is the pod, this is the name of my pod sc pod, this is a container, this is an image, and here I have mentioned regarding the volumes. My persistent volume claim name is this one which I have created. I would say here this one Azure manage hyphen disk hyphen pvc. I have mentioned the same one. Then I have mentioned the mount path. So on this path it would be mounted my persistent volume claim. Okay, pod kubectl create hyphen f pod sc.yml. You see my pod has been created. Kubectl get pods. It is showing container creating. If you see here, my is in a running stage. Let me go inside this pod. Let me firstly clear the screen. I'll mention kubectl exec -it. My pod name is scpod --sh. Okay, then I'll mention cd, and the path is mnt/azure, and then I'll mention dir. So if I'm going to create any file here, I will say touch scpod. Then this data, it is going to be stored inside the persistent volume claim, and finally the persistent volume claim will get the data from my storage claim, and then we have our persistent volume. Okay, so with this we have completed our discussion for the storage option in Kubernetes. Okay, so initially we discussed the storage at the pod level using emptyDir concept. The second one which we have discussed at the host level using hostPath. Then the third one which we have discussed using StorageClass, which works on the same principle, I would say, the persistent volume, then persistent volume claim, and finally the pod. Okay, so thanks a lot for watching the video. Thank you.